Good morning, everyone. Today we are going to learn about the Lagrange's interpolation method, which is a interpolation method where we find the uh, values in the data points. What is the interpolation? So interpolation, it is a mathematical technique for estimating values between known data points, creating a smooth function that passes through all the given points. Why we use interpolation? To predict the unknown values smoothly, fill gaps in datasets, and approximate complex functions with simpler polynomial expressions. And critical importance in numerical analysis, engineering simulation, scientific computing, data analysis, and computer graphics for smooth generation. These are the applications of the interpolation. Now, what is Lagrange's interpolation formula? Lagrange's interpolation polynomial is P of x is equals to summation from I equals to 0 to n L of x into f xi, where Lx are the Lagrange's basic polynomial that weight each known function value fxi to construct the interpolating polynomial passing through all theta points, and where L of x equals to x minus xi divided by xi minus xj, where j is not equals to I. It's the advantages of Lagrange's interpolation that it's simple and intuitive method. Works well for unequally spaced data points. No need for solving system of equations. Calculations become lengthy as size grows. Computationally slow for large data sets, prone to numerical instability with many points. Runge's phenomena at polynomial edges. Now, the problem here for given for us, we are given five data points, which is the data point and the value of their function, as you have seen here. The objective of this is we have to find the value of function at data point 9 using Lagrange's method. We need to estimate the function value at x equals to 9, which lies between our known data points. Here, the table displays the five known data points xi and fsi that will be used for Lagrange's interpolation and given in the question to estimate the value of f9. These x values represent unequally spaced points, demonstrating a key advantage of Lagrange's method over requiring equal spacing. Here, calculating L of 9, substitute as equals to 9 into the basic polynomial formula. For L equals to 9 is equals to 9 minus 7, 9 minus 11, 9 minus 13, and 9 minus 17. Divided by 5 minus 7, 5 minus 11, and 5 minus 13, and 5 minus 17 is equals to as given. Calculate L19. Similarly, for the second term, by putting the values. Now repeat these equation for L2, L3, and L4. Now substitute all values for Li9 values into the formula. P9 equals to L09 into my function value of first data point, and then L19 into my function value of second, and L29 and function value of third, and similarly for until the L4 this. And now compute the solve these things and put the values of L0 and all the Lagrange's values. So here the final equation comes, and by computing this all, we get the final answer where f of 9 is equals to 738. The interpolated value at x equals to 9 is 738. The Python program for the interpolation code is given as we firstly define Lagrange's function where we give three arguments x, xp, and yp, and the length we n equals to the length of xp list, which will be given as the argument, and the result equals to 0. Now start a for loop for I in range of n, term in which term equals to ypi, and inside that we will start another for loop for j in range n. If j is not equals to I, then term equals to x minus xp j divided by xpi minus xpj. Result plus equals to term, and we will return the result. Now we will define the two list, which is the function value and the data points, and the value at which we have to find the interpolated value. And now we have called the function and print the value. The output of the given program is will be the 738, which we have calculated in our video also. The practical applications of this method is in engineering design and simulations, data analysis and predictive modeling, scientific computing, and curve fitting. Lagrange's interpolation estimation unknown is the estimation unknown function value from known data points, simply and effective numerical technique for unequally spaced data. Python programming simplifies calculations and visualization. And we have completed the Lagrange's interpolation method. Thank you for today. Have a nice day. Like, share, and subscribe.